Okay, today we're going to learn how to determine the number of atoms of each element from using a chemical formula. Counting atoms. The subscripts in a chemical formula show the number of atoms of each element found in a compound. For example, the following is a molecule of water. So the 2 is a subscript next to hydrogen, and it applies only to hydrogen. And there's an imaginary 1 next to oxygen, which applies only to oxygen. So whatever's written to the bottom right of the symbol applies to that symbol. So if we draw a water molecule, it would look something like this. H2O means that you have 2 hydrogen atoms attached to 1 oxygen atom. So there's a total of 3 atoms in total, 2 hydrogen and 1 oxygen in 1 molecule of water. We can determine the total number of atoms of each element present. So there's 2 hydrogen, 1 oxygen. A coefficient is a number written in front of a compound or element to indicate the total number of molecules or atoms in a reaction. So a number written in front of a compound, this 2, is referred to as a coefficient. It can be written in front of a compound, which means there's 2 H2Os. So when we draw it, we would draw 2 molecules of water. And then we can count the total number of hydrogen atoms. There's 1, 2, 3, 4 hydrogen atoms now, and there's 1, 2 oxygen atoms. We can determine the total number of atoms of each element by multiplying the coefficient by the subscript. So you can draw the atoms, which I'm going to have you do in your worksheet, and count them, but a shortcut is you simply take the coefficient and multiply it by the subscript. So 2 times 2 means that you have 4 hydrogen, and 2 times the imaginary 1 means that you have 2 oxygen. So it's summarized here. Remember, covalent compounds form molecules, but ionic compounds form an ionic lattice. However, for simplification, we can draw a single unit for ionic compounds. So for example, sodium chloride, NaCl, is an ionic lattice containing many sodium atoms combined with many chlorine atoms. But we can draw a single unit for simplification. So NaCl is represented by the following diagram. NaCl means you have a 1 atom of sodium and 1 atom of chlorine, which is shown here. Here's sodium and here's chlorine. So we have 1 and 1. Okay, try part 1 of your practice worksheet and just pause the video and come back to it. Get Mr. Johal to check your work to make sure you're on the right track. And then if you are, then you can move on to the next part of the presentation. Okay, let's move on to the second part of the presentation. So compounds containing polyatomic ions. When a compound contains a polyatomic ion, you must separate the polyatomic ion into its component atoms. So for example, you have PbNO3 2. So NO3 is a polyatomic ion which contains nitrogen and oxygen. So we're going to count the total number of lead, the total number of nitrogen, and the total number of oxygen. I'm going to show you how to do that. This is more complicated, so pay close attention. So if we draw this out, we have the following diagram. So we have PbNO3 So there's one Pb. This 2 only applies to whatever's inside the brackets. So there's two NO3s. Okay? So when we draw it, we have Pb, one Pb in the center, and then we have one NO3 here, and then we have a second NO3 here. Okay, so if we count up the total number of atoms, we have one Pb, we have 1, 2, 3, 4, 5, 6 oxygen, and we have 1, 2 nitrogens. So we can count the total number of atoms of each element by drawing the diagram. It's lead 1, nitrogen 2, oxygen 6. You can draw the diagram and count it that way, which I'm going to have you do. There's also a shortcut method. In order to find the number of atoms of each element inside the polyatomic ion, we must multiply the subscripts inside the bracket by the subscripts outside the bracket. So if we take the 2 and multiply it by the 3, we get 6 oxygen. And if we take the 2 and multiply it by the imaginary 1 here, we get 2 nitrogen. Now you do not multiply this 2 by the imaginary 1 here because it only applies to whatever's in the bracket. So Pb stays as one atom. A coefficient of 2 would indicate that there are 2 lead nitrates. So you would have to draw 2 of them now. This coefficient 2 doubles everything. So if you can count it for 1, then any coefficient will just multiply all the numbers by the coefficient. So lead, there's 2 nitrogen, there's 4 oxygen, there's 12. And the way we find that is by just multiplying everything in the original table by 2. Which is what is shown here. And that concludes the presentation. You can move on to trying part 2 of the practice worksheet. Don't move on to part 3 until you've watched the presentation on chemical changes.